run class.
All right, let's get started.
Yes.
George, what are those sticky notes in that book? Show them the sticky notes.
I don't know why he like. I don't know why they're so weird. That's like the dumbest move.
All right, guys, let's go over. I think let's go over one more example of the alternate limit definition, and then we're going to move on. Talk about what 26 is all about. All those the ones that say determine what each limit below represents, without evaluating them, and then we'll talk about differentiability, and we'll be ready to be done with this section, this problem set.
I need 23.
So 22 we left off with, we had the limit as x approaches 7, right? Of 5 x squared minus 5 times 7 squared over x minus 7, right?
Yes.
That's where we would have left off. So you factor out, is it okay if I do two steps at once? If I factor out the 5 here, then what's left over is x squared minus 7 squared, which can then be factored into x plus 7 times x minus 7. And then we get a glorious cancely bovancely. And then you say, oh, now I can plug in 7. When I plug in 7, I just get 5 times 7 plus 7, and that is 70. Now there's an interesting thing to think about here, which is we showed the other day that the derivative, this gives you some good insight into how things might be working. The derivative, so let's write it like this. We showed that if y was x squared, then the derivative was 2x. We proved that with the limit definition of the derivative. Okay, which means that, for example, y prime at 7 would be 14. Now, what we just showed here is that if y was 5x squared, it turned out that the derivative at 7 was 70, which seems to suggest, right, that the derivative would have just been 10x, 5 times bigger. So what this seems to suggest is that multiplying a function by a constant just multiplies the derivative by that constant, which is a huge result if you think about it. That would be a big, that would matter a lot, right? It would mean that anytime I know a derivative, I would then know all the other derivatives. Any multiple of that function would be the same derivative, just multiplied by that number. Does that make sense? That'll be one of our big rules going forward, and it's very helpful. Makes our lives easier. All right, so set up 23. This is the last one we'll do together. I'm sure you guys can handle 24 and 25 as like a independently done problem. But if you do get stuck, we can certainly look at it. Yeah. Oh yeah. So 5x squared. So what we just showed. You have all this algebra there, right? And all that algebra shows is that at 7, at the point 749, oh no, I'm sorry. The y value is 7, what do you get there? 245, is that it? No, 343, 43? No.
How are you getting?
What's 49 times 5? What do we get there? 200 plus 45, so you get what I'm saying or no?
Yeah, 245.
Okay, so Jesse's asked, what's the visual representation? What we showed is that at this point on this parabola, the parabola was y equals 5x squared. The tangent line has a slope of 70. Now, I wouldn't attempt to draw it to scale because a slope of 70 is to the naked eye going to be pretty much vertical. It's very steep. But just as long as you get this idea that we just showed that the slope of the tangent line on that function at this particular x value was this number. Okay, so let's do it in reverse this time. So on 23, let's do the visual representation first. So 23 says, given a function f of x equals 1 over x, what is the derivative at 3? That's what we're asking. So before I even get into it, you can say, well, they're asking me to consider a function that looks like this. And then look over at the number 3. By the way, what's the y value? 1/3. Very good. And then we're being asked to find the slope of this tangent line here. Is that okay with everyone? So I'll just leave that blank for now. So we already know in advance the answer is going to be what kind of number? Negative. By the way, we already know the answer to this, don't we? We do. What's the answer going to be? -1 over what? -1/9. Because, well, how do I know that? Well, back on number 20, we actually found a formula for the derivative, right? Number 20, we showed that the derivative of the 1 over x function is -1 over x squared. So what that means is before I prove the answer, so this question is kind of a peculiar question. It's asking you to prove this result using this particular definition of the derivative. But we already know the answer is -1. Is everyone clear on that? Does that make sense? Okay. So let's prove it now using the alternate definition. So the alternate definition says that f prime of 3 is the limit of rise over run. So again, imagine you take this number and then you consider an x value over here to the right of it or to the left of it, either way. And you say, okay, well, the rise between those 2 points would be f of x minus f of 3. The run between those 2 points would be x minus 3. And then I would take the limit as my x values approached 3 from both sides. So there you go. There's the limit. Rise over run. Trey's gone.
Trey Bear's gone.
Where is he?
I don't know.
So go ahead and set that up. You should take attendance, right? Probably.
Probably.
And Liam's gone again. And William.
It doesn't make sense. It does make sense. Yes.
Okay. F of x. F of x is 1 over x. F of 3 is 1 over 3. There's your rise. What's up? The run is x minus 3. Okay, so looking at that, what should we do with that? Close. Even, I know exactly what you mean. Going to be really precise. We're going to multiply the, yes, very good. We're going to multiply by 3x over 3x. Now let's think about how do we even, sure, once you see it, you go, oh, okay. The way you figure that out when you're looking at it, is you go, oh, well, what can I multiply these fractions by that would turn them into not fractions? I don't want to have fractions inside my fraction. So the answer to that question, of course, is I got to multiply by x and multiply by 3. So 3x times 1 over x is 3. 3x times 1/3 is x. At the bottom, I'm going to leave this as just x minus 3 times 3x. And there's sort of a cancely-wincely here. Yeah, so this guy, 3 minus x, is the opposite of x minus 3. There, I mean, if that's confusing to you, pick any number you want. Pick 7. If x was 7, you'd have negative 4, 4. So these are going to be opposite of each other. So when you divide them, you get negative 1. And now you say, well, can I plug in 3 now? The answer to that, of course, is yes. Plug 3 in there, and you get the answer that we thought we were going to get. Negative 1. Cool beans? Okay, so let's move on. Take a look at 26. Interesting noise. So if any of you guys are planning to take the AP exam, this kind of question shows up with some decent frequency where they ask you about some limit. So they say, hey, what's the limit? What is this? This would be a multiple choice question typically. I've thrown a few of these into our quizzes for this class, of where you've been given this limit, and it just asks, it doesn't ask you to evaluate the limit, it just asks you to interpret it. So what is this talking about? What is that describing? Does anyone know? I'll give you a hint. What have we been looking at for the last 2 days? Well, this symbol means this. What can I maybe replace that symbol with? H, yeah. I could think of this delta x as being an H if I wanted. This is describing a derivative. So this is describing the derivative of what function? The square root of x function. That means that. Now, in this particular case, I just said you don't have to evaluate the limits. This is actually when we could evaluate this. For 1,000,000 Travis Scott burgers, could someone tell me what this is equal to? You got it, Dylan? What? No. As an answer.
I don't want to, because they don't want to do it on paper.
Doesn't require any work. We've already done the question. No.
Is it 1 2 with x 1 over x?
Jesse got it. Thank you, Jesse. So if you wanted, you could say that this limit is equal to this function. How? Why? Well, if you go back to what number was that? Was it 18 or something?
Yeah, it was like
19. So if you just look at number 19, what did we do there? We started with a function. So if you're lost now, just look at 19. Look at it. Exactly what we did was we said, what's the derivative of the square root of x function? And our first step was to write this limit, wasn't it? Now we use an H instead of a delta X, but I could have put a little banana symbol in there, right? It's the same thing. A little smiley face, maybe. So we showed, so we did a little bit of algebra, we multiplied by the conjugate, a little bit of canceling max, a little bit of algebra magic. Eventually we got from here to here. Does that make sense? So we showed that the derivative, so this, although if we drew a flow chart for what we did on number 19, it actually was, we asked this question to start, we wrote this limit, because that's the definition of the derivative, and then we ended up with this answer. But now it's math, so it's not a one-way street. You can just as easily start with this limit, be given this limit, interpret it as this limit is describing the derivative of the square root of x function, and we know that that answer is this. All right. Let's move on. Look at part B. What do we think that's describing? The derivative of what function? X to the fifth. That's all it is. Now, maybe some of you guys could guess or conjecture what would be the derivative of x to the fifth. It would be related to x to the fourth. Very good. It would be connected to that. It would, if you're curious, it would be 5x to the fourth. That 5 ends up becoming kind of a multiplier, but that's our next unit. Our next problem set is going to be, we're going to cover all the initial, all the basic rules of taking derivatives. Okay. Now C is a little different. So take a second. Don't shout it out if you know it. I want you to take a look at C and just try your best to interpret that result or that limit. Sorry. What is that talking about? So the answer is it's the derivative of the function x to the 2/3 evaluated at x equals 4. So let me show you what I'm talking about. This one's a little tricky. So I think the best way to understand this one is to first look at this. I hope we'd all agree that if I wrote that, we'd all look at that and say, that says so this is one way you can write that statement in a mathematical way. This limit describes the derivative of some function where that function is the x to the 2/3 power function. All right.